Good morning, everyone. I am Dharma. I am from mechanical branch. The subject is applied thermodynamics, mechanical engineering. Name Dharma Teja. Roll number 20951801314. The topic is what are the requirements of lubricants? How dry sump lubrication systems works. Lubrication. The prime purpose of lubrication is to reduce wear and the heat between connecting surfaces related to motion. While wear and heat cannot be completed, eliminated they can be reduced to negligible or acceptable levels because heat and wear are associated with the friction. Both effects can be minimized by reducing the coefficient of friction between the contacting surface. Lubrication is also used to reduce oxidation and prevent rust. To provide the insulation is in transform applications, to transmit mechanical power in hydraulic fluid power applications, and to seal against dirt, and water. The lubrication regimes. In the modern period of lubrication began with the work of Observant hands at the 1842 to 1912. Reynolds research was concerned with shaft rotating in bearings and cases. When a lubricant was applied to the shaft, the Reynolds found that a rotating shaft pulled a covering wedge of lubricant between the shaft and the bearing. He also noted that the shaft gained velocity, the fluid flowed between the two surfaces great rate. This because the lubricant is viscous produce a liquid pressure in the lubricant wedge that is sufficient to keep the two surfaces separated. Under ideal conditions, Reynolds showed that this liquid pressure was great enough to prevent direction contact between the metal surfaces. Taking a plain German bearing, which is known as a Steinbeck curve, summarize the lubrication regimes by describing the relationship between speed, load, oil viscosity, oil film thickness, and friction. The hydraulic hy- hydrodynamic lubrication. Basically, the lubrication is governed by one of two principles: hydrodynamic lubrication and boundary lubrication. In the former, a continuous full fluid film separates the sliding surface. In the latter, the oil film is not sufficient to prevent metal to metal contact. Hydrodynamic lubrication is the more common and it is applicable to nearly all types of continuous sliding action where extreme pressure are not involved. Whether the sliding occurs on the flat surfaces as it does is in most the bearings, or whether the surfaces are cylindrical as in the case of general plane or solvent bearings. The principle is essentially the same. Boundary lubrication. The oil film has become so thin in zone 1 that there is no hydrodynamic contribution and only boundary lubrication, which is defined by Campbell in 1969 as the lubrication by a liquid under conditions where the solid surface are so close together that applicable contact between opposing aspects is possible. The friction and wear in boundary lubrications are determined predominantly by interaction between the solids and the liquids. The bulk flow properties of liquid play little or no part in the friction and wear behavior. General classification of lubricating oils. The term lubricating oil is generally used to include all those classes of lubricating materials that are applied as fluids. Lubricating oils are made up from the more viscous portion of crude oil which remains after removal by distillation of the gas oil and lighter fraction for to it. Although crude oils from various parts of world differ widely in properties and appearances, there is relative little difference in their elemental analysis. Thus, crude oil samples will generally show the carbon content ranging from 83% to 87%, the hydrogen content from 11% to 14%. The remainder is composed of elements such as oxygen, nitrogen, sulfur, and various metallic compounds. An elemental analysis therefore gives a little indication of extreme range of physical and chemical properties that actually exist or the natural of lubricating base stocks that can be produced from particular crude oil. Chemical properties of lubricating oil: easy of starting, rapidity of warming up. The easy of starting depends chiefly on the cranking speed, which is influenced by oil viscosity at the temperature of crankcase. The major factor in the usage of lubricant is viscosity. It is not enough that lubricants should have the poorer viscosity, but also they should remain the little viscosity change within the temperature range during and after the apparent. So viscosity controls not only the frictional and thermal effect but also oil flow as function of the load, speed, temperature, and design of devices lubricated. In other words, if the equipment will often have a no make cold start, it's also important that viscosity at starting temperature is not so high that machine cannot be started. Low carbon forming tendency. This property is important to high compression ratio petrol engine where the carbon deposit will adversely affect combustion e- quality. The extent and also the composition of the such formed deposits are causing noisy and rough burning, which subjects the engine to high thermal and mechanical stresses, resulting in lowering of performance and reduction of engine life. The typical symptoms will be knocking, recognition, and surface ignition. These call higher octane fuels, which are more expensive and do not eliminate the need for ultimate decarbonizing. Thank you. Thank you for giving this wonderful opportunity to share my views. Thank you, one and all.